This video is sponsored by CuriosityStream. Get access to Nebula, the streaming service built by YouTubers like me, when you sign up for CuriosityStream using the link in the description. Hey everyone, if you've been watching my last few videos, you'll know that I just started the process of moving into a new house, and by extension, a new recording studio. Now, what this means in the long term is that I've definitely got some exciting things coming soon, but for the time being, I don't really have enough time to make videos as usual. But I still wanted to produce something. I did just buy a house after all. And so I thought that as I build my set from scratch, I might as well introduce you to some of the new props that I've been collecting over the years that will eventually go behind me and decorate this place. To start us off, I thought it'd be fun to look at this gift my mom got me for Christmas last year. Of course, she knows I'm a sucker for anything visual, which is probably why when she saw, oh my gosh, this, you probably can't even see it. When she saw this, she knew it had to be mine. What we're looking at here, if you couldn't tell, is the Tree of Life, depicted quite literally as a tree. Though, hang on, yeah, okay, it's only the parts of the tree that are still alive. Even still, this leaves an amazing diversity in life. So much, in fact, that I don't really think I could ever fully explain the entirety of this poster in a single video. Now, don't get me wrong, I talk about stuff like this all the time on the channel, whether it's the development of mammals from synapsids, the evolution of some of the earliest aquatic animals, or birds branching off from the dinosaurs. A lot of things I've talked about previously on this channel are represented here visually. But each of those topics got their own videos, and I don't really think there's any succinct way for me to explain every branch, or the entirety of evolutionary history. Luckily, I won't have to, because this poster conveniently came with a set of cards to test you on everything on this topic, and that's what I'm going to use today. Presumably, I should either know or be able to use this diagram to figure out the answers to all these questions, and I hope in doing so we'll be taken on a tour of at least what the creators of this poster considered to be the most important or interesting branches of the Tree of Life. Okay, so before we get started, I just want to say that I haven't actually read all of these cards. I've maybe read 5 or 6 of them, and I don't even know how many cards there are. My guess is like 20 or 30. Here, let me take them out. So hopefully this won't be like an hour-long video. This is what the cards look like. Oh, I was gonna say, there you go. I thought it'd be more fun to go into this with absolutely no preparation and really test my own knowledge on evolution and biology. So from here on out, I'm not gonna have a script. All right, I guess that means we can get started. First, I'm going to shuffle these. Don't judge on how I'm shuffling. I can't shuffle well. Let's see. All right, should be good enough. First card, what is it? Asteroideae are found in all of the world's oceans. During what geological period did they evolve? All right, here's our first question. During what geological period, did they evolve? So first we gotta find starfish. Asteroideae, they're right here, that's easy. I'm just gonna say they're here. Their branch starts here. What is this? The Cambrian? So these are some of the first animals then, right? Yeah. Anything before that is just like fungi, myxoans, hydrozoa, and it's just like bacteria down here. So these really were some of the first animals. That's funny. I guess that was pretty easy. I guess I can just go to the next question. Do lampreys have jaws? Where did they evolve? When did they evolve, not where? Do lampreys, I don't even know what these are. These look like weird fish to me. Kind of look like these guys, these stomiatidae, but I don't think so. They look like they'd just be right here. That'd be funny if I just spent all this time. Oh, here they are. They're all the way over here. So they're not even, all right, so here's lampreys. No, they're called Petromyzontida. When did they evolve? All right, so we answered when they evolved, right? Roughly 444 million years ago. Now we just have to answer they actually have jaws. I know next to nothing about lampreys. I've never even heard of lampreys before, so the closest thing related to lampreys are what are called Mixini? I don't know if I'm saying that. They're called hagfish. They don't look like they have jaws at all. Oh, I'm an idiot. Right here on the tree itself, it says gnathostomata, or jaws. So what it's probably getting at is that lampreys are probably like Oh, it kind of looks like they have a jaw. They're probably the first animal, the first step towards having jaws. But it says jaws, but the branch they're attached to comes off right before it says jaws. So I don't know if that means it does or it doesn't. I'm going to say it doesn't. I'm going to say, do lampreys have jaws? No. When did they evolve? Right around the Silurian time, I guess. Let me know in the comments if that's right, because I don't know. Next question is, cephalopods are regarded as the most intelligent of the invertebrates. Are they more closely related to jellyfish or clams? All right, so cephalopods, let me find cephalopods. Oh, they're all the way down here. Cephalopods, right? Cephalopod, squid, octopus, nautilus. I don't know this off the top of my head. I'm gonna say jellyfish. My guess would be jellyfish, but I guess let's find out, right? So clams are bivalves. We learned that in a previous video too. I'm such an idiot. Of course they're not related to jellyfish. Where even are jellyfish? Jellyfish are like all the way over here. Yeah, they're definitely more closely related. Cephalopods are here. Bivalves like clams are here. And jellyfish are all the way over here. So I'm gonna go ahead and make the assumption that they're more related to clams. But let's see what branch. So, oh my God, I'm such an idiot. I should have known that. This branch is clams and octopus and all cephalopods come from mollusks, which I really just made a video about. Oh, maybe I won't keep that part in. So they're both mollusks, I guess, which is weird to think about, right? You don't think an octopus or like a squid is a mollusk, because all the other mollusks like, gastropods or polyplacophora, they all have shells. And I guess I should have known because nautilus have shells, and what are the other ones? Cuttlefish. Cuttlefish and nautilus still have shells. I made a whole point of explaining that in a video. So I really should have known that, but I guess now we know cephalopods are more related to jellyfish. Or no, more related to clams than they are to jellyfish. Oh, this one's easy. This is like one video that all of these are hitting on. This question is a sponge an animal? Is a sponge an animal? I know the answer to this question already. Sponges are animals, but I don't even know where to look for them on the map. Like, what animals would they be more related to? A sponge right here. All right. Oh, so they're more related to jellyfish, I guess. Not really. Actually, they're just closer. So sponges are, I guess, what you call porifera. There's literally nothing else on this whole branch. It's literally just goes to sponges and that's it. Well, it's funny because you see the sponge branches off right here, and right below that is where animals first started. It says it 650 to 950 million years ago. Metazoa or Animalia first evolved, and at least according to this, sponges were one of the very first things to emerge. They might have been like the first big animal. I guess according to this anyway. I don't know. But sponges are animals. I guess that's what we've learned from this. All right, next question. Oh God, this is a long one. The evolution of a watertight egg on the branch of animals called Amniota allowed those animals to live fully on land. Which two living groups of mammals evolved to living back in the water full time? I'm gonna guess, what is it? What are they called? The seals are pinnipeds, right? Seals. I'm trying not to look at this as hard as I can and just answer it on my own first. I'm gonna say pinnipeds. Is it Sirenia? I don't know. It's seals and whatever whales are, I think. So let's use this. Amniota. I thought I saw that further down here. Laying eggs, watertight eggs. So Amniota starts right here, and it goes, and all of this is people who lay watertight eggs. So cetacea, that's what it is, of course. So we got cetacea, which is whales, dolphins, very closely related to like hippos and stuff. And then we have pinnipeds, right? Oh, Sirenia, that's what I was thinking of. Yeah, so manatees and dugongs are, wait, hang on. Which two living groups? So are there only two? So I guess the two living groups of mammals that evolved back into the water would be cetaceans and Sirenians, or Sirenia and cetacea. Sirenia, like manatees and dugongs, those are very related to like elephants. I think those evolved in Africa, or like I guess off the coast of Africa. I'm not quite sure about cetacea, Those might be the same story, to be honest. They're very close to hippos, which themselves are almost aquatic in their own right. So I think that answers the question. All right, next. There are over 50,000 quills on the average hedgehog. Are hedgehogs more closely related to primates or armadillos? Are hedgehogs more closely related to primates or armadillos? All right. This is something that I don't know at all. Like, I don't know off the top of my head. Hedgehogs, primates? I mean, I guess obviously, no, it's hedgehogs. Where are hedgehogs from? Armadillos are from South America, right? I don't know. I guess I'm gonna learn something too this video. Let's see, where are hedgehogs? Hedgehogs are right here. They're Eulipodophila. That's what I'm gonna say hedgehogs are called, Eulipodophila. So what am I comparing this against? Primates? Primates are here. Primates are always at the top for some reason. And then armadillos. Oh, armadillos over here. So, all right, so we start with Eutheria, which is placental mammals. And then we went over here. Yeah, I was right. So armadillos are part of Xenarthra, which is South America's animals. They branched off from Afrotheria, which is Gondwana and all that. So armadillos are on their own separate branch, but what is it? Hedgehogs and primates share what is called Boreoeutheria, which, if I had to guess, would be animals that evolved in like Asia, Europe, and North America, which I guess would make primates and hedgehogs more related than armadillos. So that's what I'm going with. Oh, yeah, the hedgehogs are Eurasiatheria, you can see that right there, but primates are not. Primates branched out on their own and became Euarchontoglires? I don't know. If I'm somebody in the comments, tell me if I'm saying that the right way. Euarchontoglires. That's what primates are. And that's what makes them more related to hedgehogs. So, question answered. Let's see, what's next? This bass has ray fins. Name 2 groups of fish that have lobe fins instead of ray fins. I'll be honest, I don't really know anything about fish. I know more about like mammals and stuff, more like land animals. I don't know. If my answers with the sirenians and the cetaceans was any indication, I don't know anything about the ocean really. So this is gonna be fun. This is learning. So ray fins. First I gotta figure out what a ray fin is. What am I even looking at? This bass. Where are the fish even on this? Fish are here. All right, so I'm looking at this fish. So bass are what you would call procanthopter. Oh my God, protocanthopteri guy. I'm not gonna say. I'm just not gonna be able to say this at all. This is ray fins, all right? It has ray fins. Name 2 groups of fish that have lobe fins. I don't even know what lobe fins are. I don't know what I'm looking at. I might have to cheat for this one, I'm gonna say. All right, I'm gonna cheat. Luckily, this poster came with the answers too. 2 groups of fish that have lobe fins. The 2 groups are coelacanths and lungfish. All right, so let's find those. Coelacanths, so we're starting here. Are coelacanths, are they further or are they somewhere else? What am I looking for again? It's not here. Neither of those fish groups are here. Okay, I figured it out. Lungfish are right here. They're called dipnoi. Or this one's actually called Actinistia. All right, so we've got dipnoi and Actinistia, and they're very far from all the other fish. All the other fish are right here, but these 2 over here make me think that, oh, of course, Sarcoptergi are lobe fins. All right, so I guess that's what these 2 branches are. So all of these would be ray fins. That's what Actinotergi. Yeah, I guess. I'm not going to say any of these very well. The Actinotergi, or the ray-finned fish, branched off from the lobed-finned fish. And by the looks of it, the lobed-finned fish, which none of these look familiar to me now, these are what ended up becoming, mammals. If you follow it, it became all the mammals. It became crocodiles, turtles, frogs. So lobe-finned fish, I guess that's why it's important, right? That's probably why it's asking about lobe-finned fish. So lobe-finned are the things that became us, pretty much. While ray-finned fish, I guess, are still just fish. But that answers the problem. I guess that's why they thought it was so worth putting on this, because it does, I guess it does ultimately show the split, the divergence in genes, right? We're not related to fish nearly as much as we're related to any of these. I guess that's what this means, is we're more related to crocodiles and salamanders and whatever these things are, way more than we are to fish. Next question. Is brown algae a plant? I'd imagine, right? Like, it looks like a plant. I don't know. Is algae like two things? No, it's lichens or something, isn't it? Algae is this, and as we can see, algae evolved before animals even existed. But that being said, here on it, it calls brown algae Straminophiles. Oh my God. I didn't even think about pronouncing all these words today. I thought this would be so easy. But anyway, Stromatophiles or Heteroconta. All right, that's an easy one. Heteroconta, which is what these are brown algae, and it has a red asterisk next to it, and it says secondary symbiosis with red algae. That is what I was thinking of. They work with another algae to produce their own energy. So I actually don't think algae is a plant now that I'm looking at it. I think brown algae might predate plants, or are what we think of as plants. I think that's what this poster is getting at, is that there were things before plants and animals that still occupied the same niches and everything, and I think that's what brown algae is. I think brown algae is not a plant, it's an algae. Is that dumb to say, that brown algae is algae? What does this say? Is brown algae a plant? No. Although their ancestor engulfed a plant alga. All right, so that's pretty much what I was thinking. So these brown algae aren't plants, but they have symbiosis with plants, I guess, or endosymbiosis. So they're not plants. Algae is not plants, or brown algae is not plants. I think I answered that question. All right, let's see. What's the next one? When was the last common ancestor of cats and catfish? That's a fun one. It's not like cut and dry. So cats are gonna be all the way up here. Filiphoria. They're mammals, if you didn't know. And then catfish. I gotta find catfish first. I think catfish are gonna be here. They're gonna be ray-finned. Ray-finned fish is probably what catfish are. So yeah, that's I had my finger right on them. All right, so catfish are Asteriophysi. Asteriophysi? But included in this family are also carp, minnows, catfish, piranhas, electric eels. So they're not closely related, is what we're learning. So if we follow this branch back down here, yeah, ray-finned fish, and then we follow this branch all the way back here, it's all ray-finned or lobe-finned fish at the end of the day. That's what we all are. I can't see. I guess it would be Euteliostomy, internal body skeleton. All right, so that's the development that that's what lampreys didn't have, right? Lampreys and hagfish didn't have jaws or any bony skeleton, which I guess was why they didn't have jaws, because they didn't have bones to have jaws with. But so they developed bones, internal bony skeleton, I should say. It really created the most successful animals in every respect. We have all the fish of all the oceans and all the, most dominant land animals. So what was the last common ancestor of cats and catfish? My answer would be Euteliostomy, right? It's just right here, but there's nothing attached to it. It's just it's not an animal. It's just a term, I guess. And the closest thing to it is this thing, oh my God. I'm going to say Chondrichthyes. Chondrichthyes are the last thing before the development of internal bony skeletons. So these came right before that. I don't know, that feels like the last common ancestor, but let's see what the answers have to say, all right? Oh. It says when was the last common ancestor, not what was. All right, so that makes a lot more sense. It was right here, about, 400 million years ago about. So yeah, this is where catfish and cats split. And this is really where all fish and land animals split. I think I answered that pretty well. Next question. The Hercules beetle is one of the largest beetles known, reaching up to 6.75 inches. Do they undergo complete metamorphosis? All right. Here we are to insects. Here it is. Yes, it looks like they do. All right. So I also don't know much about insects. I'll admit that too. So I don't know this off the bat of my head. Or off the top of my head, I should say. But looking at this table, this is why things like this are so useful. You can go from Coleoptera beetle. We're going up from beetles, and we can follow this up, and we eventually arrive here where it says Indoterigata, and underneath it says complete metamorphosis. So, come on, camera died again. Well, would you look at that? My camera died, giving me this perfectly natural break in the video to tell you all about the new channel I'm starting. You see, every once in a while over the past few years, I decided to challenge myself and make a video not about the Earth or geography, but space. These tended to push the limits of my video making abilities, and as a result have produced what I believe to be some of my best work. Though if the number of views these videos got are any indication, that's not how you all, my audience, saw them. It would appear that because the viewership I had built here on Atlas Pro expected geography, geology, biology, and ecology, or what you could call earth science, no matter the quality of the space videos I could produce, they all severely underperformed, leaving me and many in my audience disappointed. I didn't want to just stop making these sorts of videos, but I also hated the feeling of working so hard on something only to serve it up to an audience that never even signed up for it. So I'm spinning these videos off into their own second channel called, you guessed it, Astro Pro. That'll be virtually identical to this channel except with a different focus. That way I can start building an audience equally excited about exploring space with me as you all are about exploring the Earth with me. So please, if you're a fan of this channel or just science in general, check out Astro Pro and consider subscribing. There's a new video premiering tomorrow here on YouTube or right now on Nebula. More on that at the end. But now it feels like my camera is fully charged again, so let's get back to the video. All right, so we were just looking at the Hercules Beetle before my camera died. We were just about to figure the answer out, I think. So we were here, and we followed the branch back, and we found that complete metamorphosis arose with the Indoterigata. Indoterigata is where the complete metamorphosis first evolved in insects, I guess. And then we can see, following the branch, we get to beetles, which is what the Hercules beetle is. So by this, I would assume that it does undergo complete metamorphosis, which is interesting because if you follow it back, you'll find, I guess, the other insects that don't go, I don't even know what it really means by metamorphosis, if I'm being honest, but here we'll find any of the insects that don't go through metamorphosis. And those are like, I've seen these, like earwigs, grasshoppers, those don't go through metamorphosis. Or at least not complete metamorphosis. Oh, we can see where they develop wings even. That's cool. There's one, I don't know what these look like, but they're called Mantophasmatidae. And the only thing it says under them is gladiators. So I definitely got to look up a picture of those before I finish this. Then we got ice crawlers, cockroaches, praying mantids, termites. So none of these do metamorphosis, but all of these metamorphosize. And that includes beetles, like bees, like butterflies, moths, flies, I guess, and then all these other ones that I've never seen before. But I think that answers it. The Hercules beetle does go through complete metamorphosis. Next question. Is a snake a tetrapod? I'll be honest, I don't know what tetrapod means. Actually, that's not true. I think I can figure it out. Tetra means four, tetris, tetra, and pod means foot usually, or I don't have an example of pod meaning foot, but I'm pretty sure it means foot. And is a snake a four-footed creature, I guess, is what this is asking. I think this is trying to trick me. It's trying to make me think, no, right? You would look at a snake and it doesn't have any legs or feet. So it's not immediately obvious that a snake would or would not be a tetrapod, but I found snakes. They're right here. They're in what you'd call squamata. Squamata. All right, so squamata are like lizards, iguanas, and snakes. And squamata, if we follow squamata down all the way, we'll find, what am I looking for? Tetrapods, right? All right, so tetrapods, tetrapods evolved right after lobe-finned fish evolved, and almost immediately became tetrapods, which underneath it says 4 limbs, so I think I'm right there. And everything after that would be a tetrapod. All mammals are tetrapods, all amphibians are tetrapods, all birds are, ironically, all birds are tetrapods, which is funny because they, by nature, most of the time only have 2 feet. But that would also make snakes tetrapods, and I don't know what type of animal it is. Maybe I'll be able to find it. But there's some sort of animal that's basically a snake, but with really tiny arms. It's like the step between a lizard and a snake. I don't know what they're called though, but I gotta find a video. Right now, if you're watching, there's probably a video over this and probably their name too, of these little in-between evolutionary steps, but that prove, I guess, that snakes are tetrapods. Snakes are tetrapods, and snakes are also squamata. Elephants are the largest living terrestrial animals. Who are their closest living relatives? Elephants are also mammals, that's obvious, so we gotta go all the way up here, and if we follow it, like I said earlier, or like I've said in past videos, I guess, all the mammals correlate to the land masses or the biogeographic realms that they were in. So they're not gonna be on Boretheria, right? Because that's all like Asia and everything. They're not gonna be part of Xenarthra, because that's South America. They're going to be part of Afrotheria, which is, obviously the animals of Africa. And here we have Tubula dentata. Those are aardvarks, elephant shrews, tenrecs, hyraxes, and closest to elephants is, interestingly enough, Sirenia, or manatees and dugongs. And I said this earlier, I think, that whatever became Sirenians were most likely very closely related to elephants and just spent more and more time in the water until they developed, the ability to hold their breath for longer. And I think I said this in a previous video, and somebody in the comments, I remember this, somebody in the comments called me out, but I said that as elephants, or elephant ancestors, were becoming more and more marine, it's thought that they started using their trunk to breathe, to literally as like a snorkel. And there's pictures of it all over the internet, and I couldn't believe somebody said I was wrong when they very clearly still do it to this day. And you can see that elephants themselves are actually starting to become, at least better, not well adapted, but better adapted to the water. The answer is Sirenians, like manatees and dugongs are the closest living relatives, according to this, to elephants. But I think elephants are like a foot in the door of evolving into becoming their own sort of marine animals. It probably feels great being in water as an elephant though, just having all that weight taken off you. All right, next. Are birds more closely related to bats or crocodiles? And this, kind of like the snake question earlier, was, I think it's trying to trick me. It's trying to make me think that, obviously birds can fly and bats can fly. So if you don't know much, if you're not too familiar with evolution and this stuff, you might think that a bird and a bat is closely related, but I know better. I've made videos about this sort of stuff. So I know that birds aren't that closely related to bats. I don't quite know as much about crocodiles, but I guess that's what this whole chart is for. So let's find birds. Birds are here. They're called neo-aves, or new birds, and that's just, birds, penguins, all that sort of stuff. Chickens. I guess these are all birds. I guess they're aves. Aves are really what birds are. Obviously, if you trace it back, everyone's gonna say, well, birds are dinosaurs or whatever, and you find a Dinosauria right here. And then if you go further back, the common ancestor of dinosaurs and crocodiles was Archosaura. That's where they split. So things like turtles and tortoises split a little earlier. Archosaurs came about, and crocodiles diverged from dinosaurs. So the two branches on the Archosaura tree is Crocodilia and Dinosauria, and that would make birds very closely related to dinosaurs, and by extension very closely related to crocodiles. So even though they look absolutely nothing like birds and they don't fly, crocodiles are by far more closely related to birds than bats. So I think that's another question. Horseshoe crabs evolved 450 million years ago. Are they more closely related to spiders or crabs? obviously this is trying to trick me again, right? It's saying, horseshoe crabs are presumably crabs if you listen to their name, so you would imagine that they're more related to other crabs, but I have a feeling, I already know that they're going to be more related to spiders just by the question, just by the way they ask it. It's like, they're trying to play off of your assumptions, and I don't know, it makes it easy, but let's figure it out. Let's figure it out for real. So we found horseshoe crabs. They're part of Xiphosura, whatever. Horseshoe crabs, right here. They're closely related to sea spiders. That's funny. So horseshoe crabs, I guess, got their start as arthropods, jointed appendages, which I guess is just what it describes. And then one of the very first arthropods that we see, I guess it is the first arthropod, I guess other than water bears. The first big one on this branch is horseshoe crabs. And then if you follow it, we find sea spiders, and we eventually get to this part. In this part, it says arachnida, and I think I know where this is going. So 8 legs, right? We see pseudoscorpions, scorpions, spiders, wind scorpions, ticks, mites, and all of these things. So yeah, it's pretty clear from this. Horseshoe crabs are actually very closely related to spiders. They're not even distantly related. Spiders are more direct descendants of whatever, horseshoe crabs came from too. I didn't really know that. I guess if you flip them over, how many legs do they have? I'm trying to think of it. I have flipped horseshoe crabs over, at the beach and stuff, but I never really counted the legs. Maybe right now there's just gonna be a video of a horseshoe crab and we're gonna count it together. Yeah, oh look, all those legs on screen right now that I'm totally seeing too. Yeah, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, who knows? Who knows how many we've got? Do all insecta, have wings? When did wings first evolve in insects? All right, so this kind of gives away the answer, right? I'll show it to you. It asks first, do all insects have wings? Which, no, definitely not. Based on what I know, based on the insects that I'm aware of, I'm gonna say no. I'm just gonna say flat out, ants don't have wings. I mean, some ants do, but not all ants have wings. Ants are insects. I'm pretty sure. So the first answer is no. But the second question kind of answered that for you, right? When did wings first evolve in insects? So that kind of implies that there were insects before wings. So here we're looking at insects again. So complex wings evolved here with Neoptera. But then here we have Pterygata. So insecta started here, and some of the first insects, like bristletails and whatever, silverfish, fire brats, that's interesting. I've never heard of a fire brat before. Anyway, insects, and then they became winged. And then they became complicatedly winged. Because it's winged, because Pterygata is winged, and then Neoptera is complex wings. So I don't really know what that means. It's interesting because there are no living examples of Pterygata, or just winged insects. So I guess technically, complex wings developed in Neoptera, and then it looks like all modern insects came from Neoptera. Neoptera, whatever. They came from the complex winged insects. So I guess it would, based on this, I can't even find ants though. Oh, insecta is here. Are ants insects? Or am I crazy? Or am I I think they are. You'd think a tree of life would have ants somewhere, right? It can't be missing. I'm I gotta find them somewhere. Oh, ants, right here. Yeah, so ants came after the complete metamorphosis, which I guess means they metamorphosized too, just like beetles, but ants, bees, and wasps are all Hymenoptera. I guess all of these are winged. I guess I was wrong again. I guess ants are part of the lineage of insects that have wings. Let me look at where's the card? All right, so do all insects have wings? No, but some ants do. Not all of these even have wings. I'm gonna say no. You asked me this before I recorded this, and I would have so confidently said no. All insects do not have wings. But now I don't know. I'm gonna say no though. I'm just gonna, let me check the answers again, all right? It says no. Some insects are on branches that evolved before wings, which was about 400 million years ago. Okay, yeah, all right. I guess I get what it's getting at now. So these things don't have wings. Like silverfish, fire brats, whatever these are, bristletails. I guess silverfish, fire brats, and bristletails are insects that evolved before the evolution of wings. But I guess those are the only ones. I guess the rest of insects do have wings. So I was right. I was basing my logic off of a wrong example, I guess. Oh well. Are dolphins and whales more closely related to hippos or manatees? This is trying to trick you. It's trying to make you think because whales and Sirenians, because they're both aquatic, because they both live their whole lives there, that they must be related. You know, they think I'm stupid pretty much. They're trying to give me things that I'm gonna get wrong, but I'm not. I'm too smart for that. So yeah, I guess no. My answer is no. Just the way they say it, right? Like obviously the two aquatic ones aren't actually going to be as related as you think they are. But let's see that. All right. We're up here again with the mammals, Eutheria, and if we go Boreotheria, we go Laurasiatheria, all the way over here, I don't even know what this is, Cetartiodactyla. Okay, so Cetartiodactyla arrives, and then we get things like pigs, camels, ruminants, I guess? No, what am I thinking of? Even toad? Ungulates. We got ungulates. We get ungulates, we got like swine, camels, oh, there are ruminants too. Ruminants, hippopotami, and cetacea. So all of those are Cetartiodactyla. And if we look, you know, it's very easy. This is why so many people use trees of life, because they just make a lot of sense. Cetacea right here, and its most close to associate is the hippopotamus. You know, Sirenia is all the way over here. Cetacea is all the way over here. You can't even see it on the screen. So they're on opposite sides of pretty much the mammalian family. Even though they're both more similar than they are different. From what I know about hippos, they like the water, and they kind of also seem like an intermediary step between, you know, fully terrestrial and fully aquatic. And, you know, I guess their cousins, the cetaceans, were just a little faster than them. I think that was an easy question. We got that answered. Whales are very closely related to hippos and not very related to manatees. Which animal evolved first? The Stegosaurus or the sea urchin? Now, I don't really know what it's asking here. Like, I mean, obviously I know what it's asking, but I don't even think it's trying to trick me. I think it's just trying to make me use two completely different parts of this tree. So the messed up part though is that there is no picture of dinosaurs on this. So if I just tried to find a picture of a dinosaur, I would be here for a while. But luckily, we already figured out that birds are here, which means Dinosauria is right here. So now all I have to do is find a sea urchin, right? That's what I'm looking for, sea urchins, yeah. Right here, echinoderms. Sea urchins, stars, those are related. I made a video about that recently. So let's see, what's the question? Which one evolved first? You see, that's the weird thing. It doesn't even have Stegosaurus on this. I mean, I guess I know Stegosaurus is a dinosaur. I don't know why they're asking this, because sea urchins, you know, they evolved way before. They evolved around, 480 million years ago, whereas the first dinosaurs, it says, came from 200 to 20 million years ago, maybe, which I guess checks out. I guess that would make sea urchins about twice as old, as any dinosaurs or any of us, really, which I guess is interesting, but I don't know why they bothered asking that. But yeah, sea urchins older than dinosaurs. Question answered. There are 4,800 recorded species of frog. What living group of animals are they most closely related to, and when did they share a common ancestor? All right, this one's about frogs. This should be fun. Frogs are right here. What living group of animals are they most related to? Clearly, I should have guessed. I should have guessed before just figuring it out, but they're most related to, by the looks of it, salamanders and newts, or what are called urodela. Frogs are what are called anura. You can see their branch kind of just branches in two different directions, and they're very clearly very closely related. Plants adapted to living on land about 450 million years ago. What trait evolved that helped them do it? Well, I mean, this is a pretty open question, right? Open-end question, at least. Like a lot of things, the leaves, the roots, the stems, right? Everything allowed them to live on land. But I guess it's looking for something specific. So this whole branch right here is plants, I think. 450, that would put us right here. Before that, they're really just green algae, which is funny. I guess that's why it bothered asking me about algae earlier, because green algae became plants. But red algae and brown algae, well, those are just algae, I guess. But plants are here, and now what am I looking for? Plants, a living land. So what happened around 450 million years ago? It says, around 480 million years ago, it says the Tracheophyta. Here it says they have a vascular system, and I think that makes a lot more sense. A vascular system is what helps plants distribute or, transport all their nutrients and water and whatever else they're making throughout their bodies, which is not something that you really need to do when you're in water because you're surrounded by water. But when you're on land and you need your leaves to get water, but the water's in the ground all the way by the roots, you need to be able to send it up, through I think it's called the phylum or the xylem. I think one goes up and one goes down, but there's a phylum and a xylem. And I think that's what the vascular system is. This is why I write scripts, so I don't just say I think every 5 seconds, but I think that's what allowed plants to move on land, is that allowed them to, I guess it allowed them to bring water to parts of their bodies that needed it, that weren't in immediate contact with water. What kind of seeds does a water lily have? All right, if I had to guess, I don't know anything about water lilies, but seeds means that they're angiosperms, so I'm gonna go, angiosperms right here. So I think I'm just going angiosperms, water lilies. They're like the first thing. So angiosperms came from these things called gymnosperms, and gymno, I think, just means naked. So naked seeds were just naked, I guess. But then angiosperms came around, and angio, I think, means like clothed or something. I don't know. I don't know anything. But they're enclosed seeds. That's the important part, is they are more protected. They're like fruits or angiosperms, right? Like, I think this is a simple question. I think it's just asking, are lilies angiosperms or gymnosperms? And they're clearly angiosperms based on this, which means they have enclosed seeds and they flower. So I think I answered the question. That was an easy one. Did dinosaurs roam on grass? This is a good question. All right. A while ago I made a video about the biogeography of dinosaurs, and at the very end I said, I guess I could just play it. I said, heck, I didn't even get to mention all the crazy stuff that was going on with plants at the time. And I finally get to talk about dinosaurs and plants. So dinosaurs are over here. I already figured that out. And this is important, right? I'll just use this as my way of explaining what went down during the dinosaurs. So dinosaurs, we can see, are right here, and angiosperms are right here, which means they're roughly the same time. And that means angiosperms and dinosaurs didn't really spend a lot of time with each other, but they came about at the same time. So that plants dinosaurs would have seen were more everything down here. Like, I don't know how to say any of these. I was thinking ferns, but syads, like ginkgo trees, like conifers. Yeah, all right. It's making sense now. I've had a little time to think about this, and I think it's yes, because dinosaurs might have evolved here, but they went extinct. This is 66 million years ago. This is the KT extinction, I think it's called. This is when the asteroid hit the Earth and all the dinosaurs died right here. And grass is right here. So even though dinosaurs are here, they got to here. And I don't know, by the looks of it, it looks like grass came about almost directly before, or almost immediately before, or after the extinction. I would say before. I don't know if they feasted on it though. I have to imagine they fed on grass. It definitely wasn't their primary food source. I'd say their primary foods were more of these, like the conifers and ferns and stuff. I don't actually know if we know what dinosaurs ate, like specifically, but I'm gonna say yes. I'm gonna say dinosaurs did roam on grass, or at least they were on the Earth for a little while at the same time. Let me check the answers. Let me check what it says. That's what I'm saying. I'm saying no. Or I'm saying yes. Here we go. It says maybe a few. Grass did not evolve until right before the mass extinction that killed non-avian dinosaurs. They had lived for 165 years before grass appeared. All right, so this doesn't even know. I was right. I was right that we don't know, and nobody knows. So that's good. That makes me feel good. So yeah, it must have been this stuff that dinosaurs ate then. Let's see. We only got 3 left. Are spiders insects? I already know this one. I think you already know this one too. Spiders have 8 legs. Insects have 6. That's not what makes them insects or spiders, but that is a clear signifier that they're different things. And spiders, I think we learned, spiders are here. Spiders are arachnids, which, along with scorpions, and spiders are arthropods, and so are insects, I guess. Spiders are over here, insects are over here, but these aren't insects, or these aren't spiders, these aren't insects. Yeah, insects evolved after arachnids had already branched away from arthropods, is what I'm seeing. So spiders are not insects. Wings are an example of convergent evolution. Show 3 groups on the tree with different kinds of wings. All right, I think there has to be more than 3, right? I'm gonna see if I can name them all. Bird wings, right? Birds. Then we have bat wings or mammal wings. Those are 2 types, I guess, right? And then we have insect wings. I guess, are those the only 3 things? Yeah, I guess that might just be it. Wings must have evolved 3 separate individual times. You know, wings evolved for insects around 416 million years ago, and then birds were only around by like 60 or 70 million years ago. So for a while, insects were probably the only, I guess there's pterosaurs too. Insects have been flying around on Earth far longer than mammals or birds have, I guess is what is the takeaway from this card. Last one. This is funny. This is the card that was literally on top. Do ferns have seeds? When did they first evolve? So I pretty much just talked about this with grass, right? So angiosperms, this is when enclosed seeds arose. Gymnosperms were the first seeded plants, I guess. And then we can see very clearly before that, ferns are down here. Ferns are polypodiidae? I don't know. Ferns evolved before gymnosperms, before seeds evolved. And what this means is that ferns have spores. So yeah, I think that's it. I think that's the last of these cards for sure. I think I'm done with this. Here, let me put all these cards where they relate to. That's what I wanted to do. I wanted to see, once I was done, how much of this table we still haven't talked about. There are definitely some noticeable blind spots in this set of questions. I guess the biggest one I can see is all of these sorts of insects, but I guess those were covered. Like I said, we didn't cover any of the bacteria or the protozoa or amoebas or anything, but those aren't really interesting if you ask me. Not as interesting as the rest of these, and I guess we also don't know enough about their early evolutionary history because they were the first things to ever really evolve. So I guess it makes sense that we're not asking so much about this. I'm kind of surprised it didn't really ask a lot about plants. And something I noticed is that, plants take up a very small part of this tree of life, even though, in reality they make up, at least an equal aspect of the life on Earth, if not, definitely more than all the animals. So it's interesting that they didn't get as much space on this as they do in real life. What else is missing? We didn't really get to talk about most mammals, but we talked about some, so I think that's fine. Yeah, I think that's it. I think, honestly, this covered a lot. This got really a lot of the basic evolutionary history down. It didn't get, specifics, but I guess that was really up to me. So if you're left wanting anything, it's my fault, not really this poster's fault. I think what I learned is that I don't know as much as I think I do. I was going into this thinking that I'd answer every single one immediately, and I wouldn't even have to use it. This was kind of just supposed to be a nice thing to look at while I spouted facts. But what I've learned is that I actually don't know all that much about the tree of life, or many of these specific types of animals. Even the ones that I've made videos on, I don't quite have a full understanding on. So that's a lesson for me, and I guess for the audience too, right? You guys watching, it helps to know how much I know and how I know everything. But something like this with the tree of life, it's so complex, and there's so many facets that go on with every single image. Even all of these images represent a whole genus usually, or I think that's what they are. Maybe not, maybe like a family, but there is so much more to the tree of life than what's here. Not only the species that aren't alive now, but these are only examples. These don't give you every single species. That would kind of be impossible. But I think that's what I learned most about the tree of life, is it's not really important to know every single different thing, or how to say it, or every single different organism. What's really more important is understanding this as a framework, understanding how it works, so that if you're given something like this, you can use it to figure out and learn more about the world. Okay, so this is just where I start rambling and repeating myself. But now that I've had some more time to think about this whole experience, the main lesson I learned is that I should really make more of an effort to better understanding each branch on this tree. And what better place for me to do that than CuriosityStream? With thousands of high-quality documentaries, it wasn't hard for me to find the perfect place to start. Leaps in Evolution, a show where each episode is based around one of these branches, sending me well on my way to understanding how things like eyes, motherly instincts, and even intelligence itself evolved. And if you sign up for CuriosityStream using the link in the description, you also gain free access to Nebula, that streaming service built by all of your favorite YouTubers, where you can get early access to videos like those going up on my new channel Astro Pro, as well as tons of original and bonus content that you can gain access to ad-free for less than $15 a year when you sign up for CuriosityStream. So if you're like me and this video made you wish you knew more about all the various subjects we covered today, make sure to take advantage of this amazing deal. There's a link in the description, and if you click it, not only will you gain access to hours upon hours of high quality content, but you'll also be supporting video makers like me in the process. So thank you all for your time, and I hope to see you there. Hey everyone, it's me from the future to do the outro. As you can see, I'm a little bit more moved in by now, and I can't wait to show you all the stuff I plan on putting back here. If you want a sneak peek at what we're looking at in the next video, it's whatever came in this long cardboard tube. So make sure to subscribe to see what I found. If this video leaves you wanting more of me, then make sure to check out Astro Pro after this. A new video comes out tomorrow on YouTube and today on Nebula. Lastly, it's times like these that I have to especially thank the continued support of my patrons. They are in part what have allowed me to move into a new home and start a new channel. If these changes are any indication, I've got a lot of exciting things coming. So please, if you want to continue seeing this channel grow, please consider checking out my Patreon. That's it, I think. That's all I need to say. So stay tuned and I'll see you soon. Thanks.